invoke this endpoint, so I know that you are going to kill me. So this is the real problem occurs to software engineer. Kubernetes is not aware about what you do. So how are you? Today we are going to talk about something most software engineers misunderstand. So most of the videos we spend to talk about microservice design, microservice development, and some microservice pattern and practical examples, so and so forth. But almost no videos we discuss about how to correctly deploy these services on a cloud or your on-prem data center, right? So we discuss in theory microservice should be scalable and independently deployable, but almost no video we spend to talk about how we can make a microservice really scalable and really independently deployable, right? So today I'm going to fill that gap. So today we are going to talk about how we can make microservices scalable friendly. So at the beginning of the video I told that, before that, make sure you subscribe to the channel. Some more good videos to come, okay? Make sure you subscribe and also enable notifications so you won't miss anything, right? So in the beginning of the video I told you that most of the software engineers are either this concept is not understand or either misunderstand, right? So that is, they think when they develop a microservice, maybe using Node or a Nest or a Java, doesn't matter, they think scalability is the responsibility for Kubernetes or any other cluster environment to deploy, right? So our responsibility is to develop this service. The Kubernetes responsibility is to scale this service. So when we say scalable friendly or service should be scalable, we don't pay much attention on that, right? That's wrong. So scalability also a software engineer's responsibility, right? So make it scalable so that DevOps team can make it scalable, right? So you have to support it. So if you think you just develop a microservice and then you create a Docker file or and then it push into the Kubernetes or some Helm, doesn't matter what the framework you're using. If you're thinking like that, that is wrong. Yeah, it will do that job, but you have to support it. Your service, you have to write a code to support that Kubernetes can scale your service without interruption, right? So today we are going to talk about that and see how we can do it. First misunderstanding is what is the Kubernetes and what it can and what it can do. So in this, when you design a solution, you need to make sure each stage of solution has each different task to do. So there are different frameworks are there to do that job, right? It is not that same framework can do everything, right? So Kubernetes is an orchestration platform, like where you can have your containers, images running, container means running images. So you can have your containers and Kubernetes will do this orchestration part. But when it comes to the load balancing, when it comes to the terminating containers and those type of things, Kubernetes is not strong, right? Because it is not its job, right? So it is, I mean, we can talk about service mesh and why we need a service mesh, something like a linker in future videos. But today, let's see why Kubernetes, you should not give the responsibility to Kubernetes to kill your containers and how you support it, okay? This is how in simple this works, right? So I'm not going to in detail talk about the Kubernetes, but this is how usually it works, right? So to ease of this understanding, I will give some terminologies what this means. In the Kubernetes, we usually deploy something called pod, right? So maybe this is an employee service pod, right? This is an employee service pod. So inside the pod, you can have multiple containers, right? So let's say this is an employee service container. So this is auth service container. Maybe you can have a multiple containers within inside a single pod. So this is called sidecar pattern, right? So this is called sidecar pattern. Okay. So now this is a pod, and then you have something called service, right? So outside the world, talk to the service, and then service is responsible to talk to the containers inside that. Okay. So now this is the basic architecture of a Kubernetes pod or a Kubernetes deployment. So we call this as a deployment. So now how Kubernetes decide how many pods it has to run, and when to scale up and when to scale down. This is how it works, right? So when you deploy something on the Kubernetes, you are telling Kubernetes, hey, I need 3 containers. This number can be different, 3 containers initially, and you can scale up this to, let's say, 20 containers based on the load, right? So you can configure HPO, KEDA or some sort of a pod scaling framework where that can decide how you can scale. For example, you can tell if you get 10 RPS, request per second, 10 RPS, or people call response per second, right? If you get the 10 RPS, spawn new pods, right? So that means you have 3 pods running, it can support up to 30 RPS, right? If you get the more RPS, it will scale up more pods until it reaches the 20, right? That's how the basic scaling works. So now, let's say this is a pod, right? So pod is inside a node. This is important, right? So pod is inside the node. For example, this is a typical EC2 instance, okay? So now, let's say this, there are various factors to decide how many pods you can put into the node, right? I'm not going to dig into that because this is not a Kubernetes session, right? So now let's say you can have 15 pods inside this node, right? Let's say you can have a 15 pods, okay? Right? Again, this is a pod. Inside the pod you have a container. These are really Dockers, right? Employee service Docker, auth service Docker. This is sidecar pattern. This is example, but most of the time only one container per pod. But I draw this to show that there can be more. Okay. So now you have employee service. Okay. So now 3 employee service running at a starting. So that means, like, let me to draw this in a small, right? 3 employee service running at start. So let's say we are using HPA as our pod scaler, or you can use a KEDA, right? Doesn't matter. So now, like, now you get the more and more requests. So the request hit, like, let's say 40. So now pod scaler, whoever you have, decide I need more pods, right? So now it's scaling pods. Okay. So now requests are keep rising. Okay. So whenever when the RPS is climbing, the pod scaler is decide to add more and more pods. Okay. So now let's say it reached the maximum number of pods per this node. Okay. So that means I hit 15. The request RPS keep climbing, right? So now it need to add more pods, but it cannot. So at that point, it adding more nodes. Okay. So now it add more node, right? So that node again can have a pod. So that is how typical scaling works. Okay. So that scale up. So now here's the real problem comes. Okay. So now, like after 15 minutes, now request is descending, right? Number of RPS is descending now. It is like it was like 120, now it's 80, 70, 60. It's coming down. So now let's say end of this entire situation, we had 18 pods, right? But because we can go from 3 to 20, we had 18 pods, right? So that means 15 here and 3 here. Okay. Now it has to come down up to 3, right? So now how Kubernetes decide which pod should go, right? Which pod should get killed. So this is the real problem occurs to software engineers, right? Because these pods are now running, right? 18 pods started, right? So they are doing various works. Keep in mind, we discussed Kubernetes is not aware about what you do inside the container. It is not aware, I mean it doesn't aware about your business logic, right? So Kubernetes is an orchestration framework. It is up to you to tell Kubernetes, when the Kubernetes say, hey, go home, it's up to you to tell Kubernetes, no, I have some work to do, give me some more time. That is your responsibility. That means the software engineer responsibility to make sure when the Kubernetes tell you, to, hey, now I'm scaling down, go home, it's your responsibility to tell Kubernetes, give me some more time. Okay, so let's see how we can do that. Okay, so now consider this situation, right? So let's say this is service 1, right? So this, let's put the name, and this is employee service, this is a project service. Okay, so now from employee service, initial pod count is 2, and I can scale up to, let's say, 20, but right now it has 3 pods, so that means total 5 pods are running. So project service, total we can go up to 20, but minimum pod count is 1. So that we put the red dot to show that minimum pod count. Okay. So now this is scale up. Okay. So now we need to take this down. I mean, we mean the Kubernetes decide, okay, now request was like 70 TPS or RPS. So now request is descending, number of RPS is descending. So now, therefore, I need to sit down. So when Kubernetes look at this, Kubernetes sees the minimum count is 2, but I have 5. I need to send 3 people home. 3 people mean 3 pods home. So Kubernetes, let's say Kubernetes pick this, okay, let's say currently, so this one is actively working, actively doing something. So they got requests and they're processing, they're reaching the database and sorting and doing some work, right? So these two idle. But the problem is, there is no way Kubernetes to determine who's working, because they are not aware about your business logic, right? I completely understand there are workaround people do for these things, right? There are bunch of workaround people manually adding script and injecting things and to get these are aware, but that's dangerous. Dangerous mean you should not do it, because you are going to the Kubernetes territory and tell, hey, this is how you should do, right? So now when the new upgrade comes and when you integrate it with other system, it's a huge headache when you customize it. That's why it's good always follow the practice, what Kubernetes can do, and get the Kubernetes to do that, right? So now, here's the problem. They are like doing some work and Kubernetes don't know that. Kubernetes mark these pods to terminate, right? So now you will think, okay, Kubernetes decide terminates all the new pods. No. Let's say like this, right? Why Kubernetes need to keep the total count is 2, right? Because the load is there is no load now, so now 3 pods has to kill, so it decide these 3 pods to kill, and here it decide these 3 pods to kill. Okay, so now understand this very clearly, because this is so important how this works. Okay, the moment Kubernetes decide I need to kill this pod, Kubernetes setting this pod to terminating state, right? So terminating state, okay? So that means, do you remember, like while ago I explained, this every pod there is something called service, right? So it doesn't matter how many number of pods you have, there's a service, right? So this traffic is come to the service is the one who is sending the traffic to the right pod, okay? So the pod is marked as terminating and it remove that particular pod endpoints from the service. So that means the pod will not get any traffic anymore. So then step number 2 is the Kubernetes invoke if you configured any pre-stop hook, right? The Kubernetes has a few lifecycle hooks. So that means you can create an endpoint, REST endpoint here in your service, and tell Kubernetes, just before you send me home, just before you kill me, just invoke this endpoint so I know that you are going to kill me. Okay? So you can have a pre-hook endpoint. Let's say this service has a like /util / pre-stop. So then if you configure this during the deployment, Kubernetes will call this endpoint. So then so your service knows it's going to get killed. But that's optional. I usually don't use that, but you can. But why I explain this is very, very important point. Most of DevOps engineers and software engineers get this wrong. Kubernetes does not stop, does not pause this eviction process or this termination process until you respond. There's a huge misunderstanding. The DevOps engineers and software engineers trying to do is get these endpoints and run a loop or something and keep that waiting without responding, so they think the Kubernetes will wait the shutdown process. No, it does not do that. Okay, at least as of now it doesn't do that. I don't know in the future versions. Okay, right. So now I don't use this much, so you will hear why. So in the number 3, it send SIGTERM, right? So you may know there are signaling system in operating systems and used to like talk to their processors, right? For example, SIGINT, SIGTERM, SIGKILL. There are multiple SIGs. So that's why when you want to kill something, you say kill -9 and the process ID, right? So you send in the killing signal, or you can say kill -15 and then your process ID. So that is a SIGTERM, right? So SIGTERM mean you are telling this Kubernetes tells the operating system of this particular pod, hey, I'm going to kill you in a while. Okay. So now here's where you should alert. You should listen this SIGTERM. Okay. You should listen this SIGTERM and you should initiate graceful shutdown. Right. You should initiate graceful shutdown. Right. If you are using something like OpenFASO kind of a framework to deploy things, usually that framework handling this graceful shutdown thing. But if you're natively deploying on a Kubernetes, you need to make sure you are handling this graceful shutdown process, because then you can close your database connection, you can close your Kafka Redis connection, and you can eventually shut down your app server, maybe Express or something like that. Okay. So now let's say something like this. This service usually take time to shut down, right? So these services take time to shut down. So you can configure to wait some time before it really kill it. This is you can consider as a warning. SIGTERM is act as a warning. It doesn't really kill the container, kill the pod. It just tell I'm going to kill you. It's a warning. Hey, I'm going to kill you. Okay, so that's what it does. So now look at this. If you configure some value, let's say the property name, I don't exactly remember. As I remember, it's like a termination grace period in second. Termination grace period in second, right? So it's a word, right? Not the short form. Termination grace period in second. So you can configure that. If you not configure, default value, as I remember, don't count these numbers. As I remember, is 30 seconds. Okay? As I remember, it is 30 seconds. So now what happens is, SIGTERM, it's at the SIGTERM, so now you have enough time to gracefully shut down your process. If the 30 seconds is not enough, you can configure this property, say, hey, I need 5 minutes. Okay? Don't keep this like an hour or two, but you can say, hey, I need 5 minutes. So now, okay, this is again important, and a lot of engineers get wrong this. If you configure this for 5 minutes, that doesn't mean in any manner pod will stay 5 minutes to get killed, right? What it means, it gives 5 minutes to complete a process. Let's say you gracefully shut down within 3 minutes. So that means after 3 minutes, Kubernetes move to the next step. Kubernetes does not wait 5 minutes at all the cases, right? What it means, it gives 5 minutes to you to shut down and get killed yourself. Okay? Suicide. No, it's not like that. So it say, hey, it's like something like this. Kubernetes tells the pod, hey, if you have configured 5 minutes, hey, you have 5 minutes, you need to go. Okay? So if you pack your thing, if you pack everything and you can leave by 3 minutes, that's fine. Kubernetes is happy. But if you didn't go in 5 minutes, then Kubernetes will send a sig kill. Can you see here? Yes, right? Sig kill. So this is dangerous command. So now you don't have to do anything to pack your thing, close connections and anything, release the objects or resources, anything. You just, operating system will kill you, right? It just terminate you, no words to say. Okay? So again, understand this carefully. SIGTERM is giving a warning to the pod. You need to leave in 5 minutes. 5 minutes or whatever the client configure you for a graceful shutdown, right? So termination graceful shutdown period in second or something like that. I'll put it in the video when I edit, but I don't remember the property name. Okay? So default value is 30. If you, let's say you send 5 minutes, the Kubernetes will check in 5 minutes, is this guy still there? If it's not there, that's fine. But if he's still there, then it will kill it. Okay? So, what is a misunderstanding? A lot of engineers think when they send the SIGTERM and configure this property to 5 minutes, that pod will stay anyway for 5 minutes. No, it is not wrong. If it is complete within 2 minutes, it will go in 2 minutes and Kubernetes move to the next step. Okay? Right. So this is how pod life cycle works. So this is what we are going to achieve in the, I'm going to show you how we can do this. Let's say at this point you get the SIGTERM. Okay, so at this point you get the SIGTERM. And what you can do is, let's say you have this grace period for 5 minutes. Okay, so that means you are expecting in the 5th minute the SIG kill. Okay, so this is the 0th minute, this is the 5th minute. Okay, so now you are expecting SIG kill. So what we can do is, we can enforce every HTTP request to have a timeout for, let's say, 3 minutes or 4 minutes, right? So what does it mean? The moment you come here, right? So SIGTERM came, and if usually when you get the SIGTERM, you don't get any traffic, right? So let's say there was traffic came here, so you have 4 minutes timeout, right? So that means before it hit to the SIG kill, the HTTP will time out this particular request, and it can go to the graceful shutdown. Okay, understand this very carefully. So once you set the SIGTERM, it will not send any more traffic to you. Okay, but just before the SIGTERM, you may have the traffic. So that means just before this 0th minute, it has the traffic. So now you set 4-minute timeout for this HTTP request. So that means before it completes the 5th minute, just before the 5th minute, it timeout. It timeout means it can release the resource. So HTTP server has 1 minute to go for the graceful shutdown. So you will never experience the pod kill, right? Because when someone kills the pod, yeah, I mean in the logs the pod suddenly disappeared. There is no shutdown logs. It suddenly disappeared. So it's really hard to figure out what's happened, right? Because why we need to make sure when it's doing something, in the middle of doing something, if the Kubernetes kill the pod, then you have some half bake, right? Let's say you have to run for write 5 tables. The 3rd table, pod got killed. So now 2 tables remaining. There is no log saying this 2 tables is remaining to write or anything, right? So that is why we need to make sure we handle this properly. Okay. Right. So now this is the theory part. This is how theoretically this pod life cycle and shutdowning work, and this is how theoretically how we can support for scale friendly microservices, right? So next video I'm going to show you how we can practically implement this scale friendly microservice, and till then stay safe, take care.